In this video, we're going to talk about factoring polynomials that follow special patterns. So you can memorize a whole bunch of special patterns like difference of squares, perfect squares, and some other ones, or you can just kind of relate it to what you already know. Eventually, you do these enough that you probably will have the pattern memorized anyway, but if you ever forget the pattern, it helps. So here's difference of squares. And why does this work? What do you do if you forget the pattern? So this says a squared minus b squared is equal to a minus b, a plus b. So we know that this is true because a minus b times a plus b. If we expand this with FOIL, we get a times a squared, minus outside AB, oh sorry, that's plus then, plus AB, inside minus AB, and last, minus b squared. The middle terms cancel, and we're left with a squared minus b squared. So we see that it's true. But what if you forget? What if you have something that's a perfect square and you forget the pattern? So really, this is similar to something like a squared minus 4, which is also a perfect square, just like the b squared is a perfect square. So we need perfect square minus perfect square. So if you forget the pattern, this is like a regular trinomial, but the x term is missing. How many x's are there? There are 0 x's. Now we can follow the man rule. We need numbers that multiply to 4, or negative 4, and add to 0. What multiplies to negative 4 and adds to 0? We could try 1 and negative 4. That would give us negative 3 when we add it. We could try negative 1 and 4. That's going to give us positive 3 when we add it, but we want 0. So how about 2 and negative 2? When we add those, we get 0. So we can see when we factor it, our numbers are going to be plus 2 and minus 2. So even if we forget this pattern for difference of squares, we can still figure it out using simple trinomial factoring. Okay, but if we got something a little more complicated like 9x squared minus 25y squared, it might be a little bit harder to use the simple trinomial. So in this case, it's good to have the formula memorized. But again, if you forget that a squared minus b squared is equal to a minus b times a plus b, you could just make yourself a simple little example, work it out, and then go, oh yeah, of course, that's what the pattern is. So if we're going to use the pattern here, the first thing is a squared. So this whole thing has to be a perfect square. How can we write 9x squared as a perfect square? As something squared. Well, something squared is going to be 9, that's 3, and x. So this is now written as a perfect square. That's our a value. Okay, now we need to do something with the 25y, the minus 25y. So 25y squared, we want to write that as a perfect square, so it can be b. We need to have something squared, so we have 5y squared. So that's the value for b. So plus b, plus 5y, and minus b. Oops. And we're done. We're done factoring this difference of square question. You could be given an even more complicated question that kind of looks like difference of squares, like y squared, x squared minus y squared minus y minus 36. So this question kind of looks like difference of squares, but if I just factor the beginning, I still have stuff left over at the end. So this is not in factored form. If it's in factored form, every single thing is multiplying, and we have multiplying, multiplying, subtracting, subtracting, not factored form. Well, what if we try to factor the second part? I see I can take out a common factor of 12, and then I have y plus 3. But there's nothing else I can do here. So this is not going to work this way. So for a challenging question like this, you just have to keep trying things until you find something that works. I can see that this part right here, with the y's, it kind of looks like a simple trinomial. So I'm going to try factoring that and see what happens. I'll take out a common factor of the negative, so it's a little bit easier. Now for following the man rule, we need something that multiplies to 36 and adds to 12. There are so many things that multiply to 36, so this has so many choices. We could have when you have so many things that multiply, it's often a good idea to write out the choices. Okay, that last one's 36, just didn't fit on the screen. Okay, so if we tried 1 and 36, that's not going to add to 12. 2 and 18 will not add to 12. 3, I just need to make some little lines here to match them up. 3 and 12, note that adds to 15, not 12. 4 and 9 adds to 13, and then 6 and 6. 6 and 6 multiply to 36 and add to 12. So we found what we're looking for. So the numbers are 6 and 6. Okay, so I see I have the same binomial twice. Oh, and I accidentally changed those y's to x's for no reason. Okay, so does this fit any patterns that we know? We have a perfect square minus a perfect square. So we have difference of squares. So this is where knowing the patterns comes in handy. At least you can identify it. And so this means we have x plus what's in the bracket and x minus everything in the bracket. Okay, and we can just simplify a little bit. We won't have anything to collect because we have x's and y's. But it might look a little bit better. Okay, so it's a fairly complicated difference of squares question, and it might take more than one try until you figure out how you can factor this fully, but just stick with it and try your best.